Okay, welcome back. In this screencast, I'm going to take you through how to do a little bit of problem solving. Okay, so in the upcoming lab for week 3, we've designated a project Euler problem for you to solve to demonstrate the skills we've hopefully taught you so far. And what I'm going to do here is actually solve a project Euler problem for you, so you might get some insight into how I solve problems, and then maybe you could take something away from that, and that'll help your own problem solving technique. Okay, there's no right and wrong way, so have a look at what I'm doing and see if that helps. So what is Project Euler? It's a website. Project Euler is spelled like this. Here's the website. Okay, so up the top here we have problems. Feel free to make an account if you feel like it. It's probably a good idea to do that if you wanted to see what the correct answer is. So you can't actually see what the correct answer is right now. If you log in with an account you've created, you want to check if your answer is right, and the website will tell you. Okay, so problem number 1 is, if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. Okay, so hopefully that's straightforward enough. And for my problem solving technique, the first thing I ask myself is, how do I do this on paper? Okay, I'm not going to add up the multiples of 3 or 5 below 1000. That would take me a very long time. So I start off with, how would I do this on pen and paper for a very small scale version of this problem? Let's say, for example, multiples of 3 or 5 below 20. Alright, let's go back to MATLAB. I'll clear this screen. I'm going to use MATLAB to hopefully convey what it is I'm trying to do, because writing like with a virtual pen might be a little bit messy and a little bit more difficult. Okay, so with pen and paper, I want to add all the multiples of 3 and 5 less than 20. Okay, so naively and very simply, I might do something like 3 plus 6 plus 9 plus 12 plus 15 plus 18. All of these numbers are multiples of 3. All of them are less than 20. Okay? My answer for that is 63. This is probably useful, so let's keep this in some variable. I'll call it A. So part 1, all my multiples of 3 are equal to 63. Part 2, B, all my multiples of 5 less than 20. I think that's less than or equal to, by the way. Let's go with less than or equal to. B is equal to 5, 10, whoops, 15, and 20. Okay, so you might expect that your answer, C, is this. There's actually one little problem with this. It's a little bit of a trick. If you've gotten this far in your problem solving, that's great, that's good. However, there is one problem. 15 is used twice. Okay, so multiples of 3 and 5 are going to coincide on multiples of 15, because 3 times 5 is 15. So all I need to do is say that C is equal to C minus 15. And there's my addition of all the multiples of 3 and 5 less than 20. Okay, so those are the basic steps. How do we get a computer to do it? Okay, so step 1. What did I do here? I generated all the multiples of 3 less than my endpoint number, which was 20. And step 2, I did the exact same thing. All the multiples of 5 less than 20, and including 20. Okay, so let's make a new script. New. So, to start with, let's do a for loop, okay? Because a for loop is a good way to increment a number. So I'll say for I is equal to 3, okay, in steps of 3 up to 20. I'm still going to use 20 here because we know what the correct answer for 20 is. It's 98. Now, this syntax is perhaps a little bit different to what you've seen before. So you've seen before that 3 to 20 will generate all the numbers in steps of 1 from 3 to 20. Okay, what happens when I do 3, 3, 20, like so? I said it before, but it means we generate in steps of 3. Okay, so I get 3, 6, 9, 12, 15, 18, which is very similar to what I did up there. Okay, so depending on the endpoint, we get all the numbers from 3 in steps of 3 up to 20. Okay, so this is a good starting point. Now, what am I doing with these numbers? So I is going to start at 3. Next time around, it's going to start at 6, 9, so on and so forth. I want to add that, right? I wanted to add this together, okay? I can't add all these numbers at the same time right now. So what I'm going to do is, before I get started on this for loop, I'm going to make a variable called count. So I've made a variable called count. This is going to store all of these numbers into count. So obviously we have to start with 0. What I'm going to say is count is equal to I. Okay, so every time this for loop runs, the count should update. Let's just see what happens when I run this. Okay, I'll clear this and go through this with you. So count starts at 0. Nothing too special there. This generates all the multiples of 3 less than equal to 20, and count is going to be equal to I every time. Finally display, we will display count. Let's run this. It asks me to save a file name. I might just call this PE1 for Project Euler Problem 1. The number I got was 18. So even though I didn't add multiples of 5, this is a pretty big difference between 18 and 98, which was my correct answer from before. So the problem here is actually that every time this for loop runs, count is being updated. It's not actually being added to, it's just being updated. So 18 is the largest multiple of 3 less than 20, so 18 is the last number that's displayed in count. So how can we fix this? I'm going to say instead count is equal to count plus I. Okay, so every time this for loop executes, it'll say for the first time through count is equal to 0. So 0 plus 3 is equal to count. Well, count is now equal to 3. Next time through, count is already equal to 3. So 3 plus 6 equals 9. And this is actually the desired effect. Run this code, 63. That's much better. Okay, so now we need to consider the multiples of 5. So let's do the exact same thing, except multiples of 5. Count equals count plus I. End. 113. That's exactly what we got before. That's great. Except we have that difference of 15 because of the multiples of 15 coinciding. So what's one way we could do that? I subtracted 15 off, okay? And that was because I knew there was only one multiple of 15 less than 20. But how many multiples of 15 are there less than 20? Let's just use MATLAB to do that for us. So we can do the exact same thing, 15 in steps of 15 up to our endpoint, which is 20 for now. Count is equal to count minus I. So for every multiple of 15, we subtract it instead. Now we get the correct answer. Okay, that's great. So if I was to do this for 1000, we should get the correct answer. And yes, I believe that is the correct answer. That's a pretty big number. You're not going to do that on pen and paper. But hopefully I've taken you through the steps that I would have taken on pen and paper to get this result, okay? So we're using a computer to do the tedious things. We generally don't want to repeat ourselves as human beings. That's what computers are for, okay? So is there a better way to do this? There definitely is, okay? For a start, we might do something like, at the very top, I like to make a variable called limit, okay? And limit might be the endpoint, right? So I was using 20 here before, now I'm using 1000. I'm going to call this 20 again. And now I'm going to change all of these to limit. So now every time I want to change what the endpoint is, I don't need to do it 3 times. I just do it up the top. I get my correct answer back from before. That's great. Okay, what else could I do?